Hello and greetings. Allow me to introduce myself. My name is Judisthira with student ID number 211011050039, and I brought a topic about thermochemistry, or specifically about Kirchhoff's law, dependence of the reaction enthalpy on temperature. But then, what is thermochemistry though? I'm glad you asked. Thermochemistry is the study of the heat energy which is associated with chemical reaction and/or process change such as melting and boiling. A reaction may release or absorb energy, and a process change may do the same. But don't you think it's too general? Of course, yes. That is why I'm back here to talk about dependence of the reaction enthalpy on temperatures in Kirchhoff's law. That is what I'm trying to cover here, about the dependence of the reaction enthalpy on temperature in Kirchhoff's law. Kirchhoff's law describes the enthalpy of a reaction variation with temperature changes. In general, enthalpy of any substances increase with temperature, which means both of the product and reactant enthalpies increases. But it's boring when you talk about the material stuff. Can we skip to the equation instead? Alright, if you say so. For any given chemical, the enthalpy at temperature T is equal to the enthalpy at the room temperature plus a correction. The correction is the integral of Cp dt. Well, pay attention to the T prime. It's a dummy variable. We use the T prime because it's used at the upper limit here. Therefore, we need a different variable. We use T prime, but we can use X instead. The reaction enthalpy is often given in joule or kilojoule per mole reaction. Thus, we have the enthalpy after reaction at temperature T is equal to the enthalpy of reaction at the room temperature plus the correction. Where is the delta CPM? That's simply the CPM of the products minus the CPM of the reactants. How do we understand it? To calculate the enthalpy after reaction, for example, the A to B reaction at temperature T, we can divide this reaction into 3 steps. First step, we convert this A at temperature T to A to temperature room, and then we change the temperature of B to the room temperature to temperature T, the target temperature. If you look at the 3 steps process, A at temperature T and to the B at temperature T, simply because enthalpy is a state function. We came to this section of a popular questions. Because I'm in a good mood, let's have some Q&A. How is enthalpy dependent on temperature? The temperature dependence of enthalpy is determined by a parameter called the specific heat capacity, or at constant pressure, or Cp. If Cp is more than 0, then enthalpy will increase with increasing temperature, whereas if it's less than 0, enthalpy will decrease with increasing temperature. What is temperature dependence equation for the molar enthalpy? Delta H equals Cp delta T. If the temperature dependence of the heat capacity is known, it can be incorporated into the integral in equation 3.5.2. A common empirical model used to fit heat capacities over board temperature ranges is. After everything that we've been studied, physics is actually fun, isn't it? It may look complicated at first, but then you will realize it is actually very easy. My lecturers once say it is actually very easy, yeah, and I just realized it is. Have fun studying and see you next time.